Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about examples of elementary functions, and in particular, this video is just going to focus on the piecewise defined function. Okay, so when you talk about the piecewise defined function, it is really about we can simply say that it is just about having different formulas in different parts of the domain. So if, for example, you have function fx here, so your domain is x, so this is the domain, and based on this graph here, I'm sure you can identify that they are sort of three different parts. So the first part starts from this point here, so this is point 1, point 2, so it starts from this part. It's going in this direction, so it's going in the left direction, and you can see that for x less than 2, so this is the domain where x is less than 2. Why is it less than 2? Because you can see that for this one there is an open circle, which indicates that it does not include 2 in the consideration. So when x is less than 2, you can see that the graph here is just a simple quadratic function, which is equal to x squared here. So the function of fx is equal to x squared when x is less than 2. Now at this particular point here, there is this a full circle, which indicates that x is equal to 2. So this is exactly includes 2 in the consideration, and when x is equal to 2, the value of y is equal to 6. So when x is 2, the value of y is 6, and we can say that fx is equal to 6. So y here is the same thing as fx, okay? Next, we have another area that you can consider here based on the graph given. You can see that this is the area, this area here. This is the area where x is greater than 2. Why is it greater than 2? Because this is an open circle, which means it doesn't include 2 in the consideration. So it is greater than 2. So we're going in this direction, and we're going to stop at 3, 4, 5, 6. So we're going to stop at 6, and since this is a full circle, that means 6 is included in the discussion, in the consideration, and therefore the domain can be written as x greater than 2 and x less than or equal to 6. And for this one, clearly that this function, this graph here is a straight line. It's a straight line graph, so the function is going to be a linear function, and this is equal to 10 minus x. Okay, next we are going to consider a very simple example, which is to sketch the graph of the absolute value function. Fx is equal to absolute value of x. Now, if you find difficulty in sketching the graph, the first step that you can do is consider what are the possible values that x can take. Okay, so now we are going to, start thinking of the possible values which x can take, and practically we are going to choose values that are easy to compute. For example, values such as -3 or -2, -1 and 0, or 1, 2, 3, and so on. Okay, so here is the function which is absolute value of x. Now when -3 is substituted into x, the result is going to be positive, so the answer is going to be 3. -2, absolute value of -2 is going to be 2. -1 is 1, 0, 1. Positive value of x, the result is going to be positive, so for 2 here it's going to be 2 and 3. So based on these functions, you can start plotting these points and see how the graph will look like. Okay, so simply sketch the graph. This is the y-axis or fx, okay, and this is going to be the x-axis, and roughly this could be 0.1, 0.2, 0.3, -1, -2, -3 maybe. Next we have 1, 2, 3. So next the points could be here 1 and 1, 2 and 2, 3 and 3. Next -1 and 1, -2 and 2, -3 and 3. So based on this, I'm sure you can see that we are just having a simple straight line graph that looks like this. I'm just connecting the dots. I'm not sure it looks perfectly straight, but you get the idea. I hope so. The graph is going to look like this, more or less. Okay, and based on this you can see or you can construct separate functions depending on the separate parts of the domain. So we can see that, let's look at the domain here. You can see that this could be one particular domain where x is less than 0, and then we can have another domain which is from this point, it includes 0 and it goes in this positive direction here. So for this one, this is just a straight line that passes through 0, and you know that this function is just going to be fx is equal to x for this particular domain. Okay, next for the second part here, for this area here, you can see that this is a negative slope. It has the same feature sort of compared to this graph here. So we know that the graph here is going to be fx is equal to negative x, and therefore we can rewrite this function in terms of piecewise function, which is going to look like this. So fx is going to be equal to -x for x being less than 0, and fx is going to be positive x for x greater than or equal to 0. So this could be the way to write the function in terms of piecewise function. Okay, next let us try to find a formula for the function f graphed in the following figure. Okay, so based on this graph here, you can see that we may have 3 different parts. So this is the first part. Okay, and then this is the second part, and this is the third part of the domain. Okay, so based on this, you can see that the domain starts at -3 and it is going in this direction. So -3 going in this direction. So first of all, so I'm just going to define the domain. So fx is equal to the first domain here is x less than -3. So that's the first domain. The second domain is from -3. So this one is full circle, so that means it includes -3, and it stops at x equals to 0. Oh, sorry, x less than 0. Okay, it doesn't include 0 because this is the open circle. So now the second domain is -3. X is between or greater than or equal to -3 and less than 0. And the last domain here is x is greater or equal to 0. Okay, so x greater than or equal to 0. So those are the three domains. Next, for the first part of the domain here, we can see that we have a simple horizontal line here, which says that no matter what the value of x is, y is always going to be equal to -3. So for that purpose, we know that this can be represented as y is equal to -3, and we can write down -3 over here. So fx is equal to -3 for x less than -3. Next, for this one here, for this function, in order to know or to construct this function, you need to know the 2 points. So the first point here is -3 and 6. So the coordinate here is -3 and 6. And this one you can think of as having 0 and 3. Okay, so based on this, you can construct the slope. So what is the slope? The slope is m. So m is equal to y2. So this is the formula to compute the slope, in case you don't remember. So this could be the first coordinate and the second coordinate. Then we can have 3 minus 6 over 0 minus -3, which is +3. So there we have -3 plus 3, which is -1. So next, based on this, you can construct the equation here using this formula, which is y minus y1 is equal to mx minus x1. So you can take y1 to be, you can take this as your y1 and x1. So we have y minus 3 is equal to -1, x minus 0, and this can be further simplified as y is equal to -x plus 3. Okay, so I'm going to write down my fx here is going to be equal to -x plus 3 for this region here. Okay, and finally, for x greater than or equal to 0, we are having this simple straight line here, which says that doesn't matter what value of x is. If x is 2, y is going to be 4. If x is 6, y is still going to be 4. So it doesn't matter what value x is, y is going to be 4 all the way, in this direction. So for that purpose, we can write down fx is equal to 4 for x greater than or equal to 0. All right, I think that's all for now. Thank you very much for watching, and I'll see you in the next video, and we're going to talk about other types of elementary functions.